So we've come a long way since our initial ratio 3 to 5. 3 alpacas in my herd, 5 alpacas in your herd, since the start of this section. These are 4 very different representations of the same ratio that I'm going to give you. The ratio of births to women 15 to 54, which is a part to part. Note the fine print in the table above does not include 10 to 14 and 45 to 54 in this statistics for all ages. The ratio of absolute numbers is difficult to comprehend given the size of the two numbers. So to know what this number is, 3 or 4 million over 63 million, it's difficult to understand. But when we divide it, we turn it into that decimal. It's just dividing two numbers. But the simple decimal 0.0625 hides the ratio. It's actually two numbers. When you divide a ratio, you still get two numbers, but the bottom number is 1. This is actually a unit rate, which is per 1, woman age 15 to 44. That is 0.0625 per 1 woman, 15 to 44. But this number is very small, and people don't like messy decimals. The fraction is nice. The number is manageable. 6.25 births per every 100 women aged 15 to 44. And then finally, the percentage, 6.25%, conveys the same information as this, exactly the same information as this fraction, but uses shorthand to represent dividing by 100, which is this little decimal and percentage. Many people memorize the rule that to go from a decimal, which is this, to a percentage, you multiply by 100. Technically, that's not correct. What you're doing is multiplying both the numerator and the denominator by 100, which really is just 1. Right? Multiplying by 100 changes the magnitude of the number. Multiplying by 100%, which is 1, does not change the magnitude of the number. As we learned in chapters 2 and 3, it just changes the representation to a percentage. We will use the following rules, right? To switch between decimal and percentage representation, use the following. To represent a decimal as a percentage, first write it as a fraction over 100 by moving the decimal 2 spots, right? Moving the decimal 2 spots is the same as multiplying it by 100. So you're really multiplying by 100 over 100. The numerator is then a percentage in question. To change from a percentage to a decimal, first write it as a fraction over 100 and then divide by 100, which moves the decimal 2 spots to the left. So that's just how you go from a decimal to a percentage and from a percentage to a decimal. So we're going to do one more example. Remember that percentages are used like other rates to make a comparison between absolute numbers, like the number of people in each state with a college degree, which is what we're going to look at now. Here's the number of people in each state with a college degree, the percent and the amount of people with a college degree. This is actually sorted by percentage, by the percentage of people in the population of the different states that have a college degree. So it's the percent of the population 25 and over with a bachelor's degree or higher. You might expect like Massachusetts would be up there because of all the people, all the schools that they have in Massachusetts. Harvard, Boston College, Wellesley, Amherst, University of Massachusetts, the list goes on and on. It's a really extensive amount of colleges there. So using the following graphic, explain why Massachusetts is number 1 and Georgia is number 22, even though they have roughly the same amount of residents, 25 and older. with the degree. So what they're saying here, there's Massachusetts got 1.78 million people with a college degree or over. Georgia is way down here with 1.77 million. So they have almost as many people with a college degree. Why is it ranked down here and Massachusetts is ranked up here? And the answer is simple. Because Massachusetts has less people, so it has a higher percentage with people with a college degree. Massachusetts is number one in the nation with 39.4% of residents 25 and older having a bachelor's degree, and Georgia is 22nd with 28%. So 39.4% is the same thing as 39.4 over 100, which is the same thing as 0.394, right? The base for 39.4%, this number here, is the population of state residents 25 and older. This one right here. There's 39.4 people with a college degree for every 100 people 25 and older. So here we're going to figure we're solving for how many people there are in Massachusetts that are 25 and over. There's 39.4 people with the college degree for every 100 people, 1.78 million people with college degrees 25 and over the total amount of people. So there is the total amount of people 25 and older in Massachusetts. This is how it can be done algebraically. 39.4% of, meaning multiply, some unknown number. So if you take 39.4% of some unknown number, you will get 1.78 million. Divide both sides by 0.394, right? That's because that's 39.4 over 100. And you get that. So that's an algebraic way of doing this. So the algebra is it's really identical. It's just you're sort of skipping steps here. Okay, from the chart, determine the number of residents 25 and older in Georgia. And we're going to do this both with a proportion and with algebra. So let's go up here and look at the data that we have from Georgia. 1.77 million people, 28%. So that's the number of people with a college degree. That is saying that 28% of the population has a college degree. What is the population 25 plus in Georgia? So this really is nothing more than we did before. I'm going to set it up part to whole, part to whole. So you might want to pause this and see if you can do that. So there is our answer. With this information, That's the proportion. Cross multiply, divide, and that's what we get. Now I'm gonna do it algebraically, okay? So I'm gonna move this down and do this algebraically. So it's really 28% of some unknown number equals 1.77. Now, you're not gonna use 20, that's 28%, so that's 28 over 100. Best to do this right away, and then divide both sides by 0.28. And you get the same thing that we got over there. X is 6.32 million. So there's 6.32 million people in Georgia over the age 25 or older.